So if you find the chapter on simple cells confusing, because there are many terms you need to memorize, negative electrode, positive electrode, anode, cathode, and you get confused, what I'm going to do is I'm going to show you a simple way to derive all of that with little to no memory work. Hi everyone, it's Jeremy from the classroom, and let's get started. So here, first of all, what I'm going to do here is this. I'm going to talk about what a simple cell is. It basically makes use of a chemical reaction to produce electrical energy. All right, think of it like a battery. Okay, so a very common setup, of course, in a simple cell is that here in the middle you have a voltmeter or a light bulb instead of a battery. So some of you may ask, where is the battery? Well, the simple cell, which is this box here, all right, what's happening in this box here, the simple cell, will produce electrical energy. All right, so now what I'm going to do here is this. I'm going to label. So the most common setup we will see, of course, is copper and zinc. All right, and we will use an electrolyte. In this case, I'm going to use sulfuric acid. You can use any other electrolyte, sodium chloride, copper sulfate, doesn't matter. As long as it conducts electricity, you're fine. Now, so when you come across a simple cell setup, the first thing you want to do here is this. You want to look for the more reactive electrode. And the more reactive electrode is zinc. Okay, so what's going to happen is the zinc being more reactive will lose electrons more easily, and electrons will flow out of zinc into copper. All right, so electrons flows out of zinc into copper, and copper receives electrons. Okay, so once you understand that, all right, I'm going to also write an equation. So zinc will form zinc ions equals by losing electrons. And so what's going to happen is, if these were your zinc atoms, all right, they would slowly make their way into the electrolyte. And as a result, 2 electrons go up. Your electrode becomes a lot smaller. Let me just color it in white to give you a bit of idea what's going on. All right, so you can see. Hold on. There we go, white. Okay, so this electrode this atom kind of goes into the electrolyte, so that's gone. All right, let's do one more. So another zinc will form a zinc ion, and same thing, the electrons will basically move into the wire, and when that happens, this zinc atom also kind of disappears. And as a result, what you will see is your zinc electrode become smaller and smaller in size, so it will decrease in size. Now, on the other hand, what's going to happen is that electrons are going to flow into copper, and as a result, copper becomes negatively charged. All right, and this will attract your cations, which, if you think about the ions present in sulfuric acid, it's H plus SO4, 2 minus, H plus OH minus, and the cation that will get discharged is your H plus. So your hydrogen ions, H plus ions, aqueous state, all right, they will gain electrons to form hydrogen gas. Okay, so that's your equation at the zinc and copper electrode. Now, what about naming? All right, now, once you identify the more reactive metal, we know that electrons flow out of it, right? Okay, now if I were to get you to compare this to a battery, now we know that for a battery, plus minus, electrons flow out of the negative terminal, all right? And they flow into the positive terminal, out of negative into positive. So if on this side, electrons flow out of negative, let me use black color again, out of negative here, all right? Your zinc becomes your negative terminal. On the other hand, electrons flow into copper, so they flow downwards into copper. As a result, copper becomes your positive terminal. Okay, so without memory work, right, you just need to recall that zinc is more reactive, number 1. It loses electrons more easily. Number 2, electrons flow out of zinc, hence zinc is negative. All right, electrons flow into copper, and that makes copper the positive terminal. But wait, okay, once again, let's recall this. Copper, electrons are flowing into copper, and that makes copper negatively charged. All right, as a result, it will attract your cations. Cations get discharged. All right, okay, so the positive terminal is negatively charged. All right, okay, so I hope this gives you a much clearer idea on how to name, how to look for the negative terminal, the positive terminal, all right, and based on flow of electrons, how to find the negatively charged, because that's where cations go to get discharged.